There are other ways that we survey the Earth which Eratosthenes never dreamed of. NASA scientists use airplanes and satellites.
But what if we wanted to survey other planets like Mars?
NASA scientists are doing that right now. But first, let's head to Central Middle School in Charlotte Courthouse, Virginia. There, students are following in the footsteps of Eratosthenes.
Hi, we're from Central Middle School in Charlotte Courthouse, Virginia.
NASA Connect asked us to show you how to do the student activity for this show. In this lesson, you will work in small groups to take accurate measurements of shadows using geometry to determine the size of an angle. Here are the materials you'll need for each group. A straight stick approximately 91 centimeters long, a meter stick or tape measure, a piece of string approximately 91 centimeters and a rocker weight, a scientific calculator, index card, compass, copies of the student data chart for each student. Let's begin. Divide the class in research groups of 3 to 5 members. Set your measurement station by first placing the gnomon perpendicular to the ground. For your measurement to be accurate, it is critical that the gnomon is vertical. To check the vertical position, tie the rock or weight to the string and dangle it above the ground in front of the gnomon. Next, measure the height of the gnomon. Place an index card under the station to mark where the shadow ends. Take measurements every 2 minutes, beginning at least 10 minutes before local noon, which is the time that the sun is highest in the sky. This will most likely not be noon, as indicated on your time measuring device. Students should note that when the sun is highest in the sky, the shadow length is the shortest. Since the edge of the shadow is fuzzy, and the shadow is moving from east to west in the northern hemisphere, be careful in deciding where to place your mark. Record your data on data chart 1. Now, back in your classroom, locate the latitude and longitude of your school location and record it on data chart number 1. Identify your best shadow length. This is the best shadow length at local noontime. Next, calculate the tangent by dividing the length of the shadow by the height of the gnomon. Locate this number, or the nearest rounded number, on the tangent table. The measure of the tangent can also be found by dividing the length of a shadow by the height of an object on the scientific calculator. Record tangent on student data chart. Make a scale drawing of your gnomon and shadow. Complete the triangle and measure the tangent with a protractor to verify your calculations.
What's next, Jennifer?
Let's analyze the data by reviewing the results of this activity and by responding to the following questions. Did the weather conditions affect the results of this activity? If so, how? As the shadow lengthens over time, how will the angle be affected? If each group uses a gnomon with a different length, how will that affect the results of this activity? For more activities like this, check out our website at edu.larc.nasa.gov/connect. NASA Connect would like to give a special thanks to the mentors from the AIAA chapter at Howard University in Washington, D.C. We appreciate all your help with the student activity.